Hey guys, Mr. Middleton here. Today we're going to talk about factoring the greatest common factor. This is going to start our factoring part of this chapter. We just got done multiplying, and well, you'll see that it's kind of like multiplying backwards. Okay, see if that helps out. All right. So by the end of this video, you should be able to factor a monomial from a polynomial. And like I said, factoring a polynomial basically reverses the multiplication process. By the end of the problem, it should look like the beginning of a multiplication problem, basically. Okay, the first thing that we'll want to do is find a GCF, or the greatest common factor. Okay, so here's an example that we'll go through kind of a little bit more in depth. I won't expect you to do this every problem, but I want you to see what we're doing kind of with more detail. So we have 4x cubed plus 12x squared minus 8x. We want to factor this problem. Okay, and there's two steps to factoring. The first thing that we're going to do is we're going to find the GCF, the greatest common factor, and then we're going to factor it out. We're going to take it out. And this is how we'll find that greatest common factor. I have all the terms listed out here: 4x cubed, 12x squared, and 8x. And I'm just going to list out basically how you multiply to get to them. Okay, so 4, I can get to 4 if I do the prime factorization. I can do 2 times 2. Okay, that gives me 4 times x times x times x gives me x cubed. I'll do the same thing with these other numbers as well. So I have 3 times 2 times 2 times x times x. And here I have 2 times 2 times 2 times x. Alright, so this is how we factor, or the prime factorization for each of these terms. Now we're trying to find the greatest common factor, and so common means alike. Greatest is the biggest thing that's alike in everything. Okay, so what I'm going to do is I'm going to find out what's in everything. Well, I have a 2 in everything. I have another 2 in each of the terms, and I have an x in each of the terms. Okay. As we look at the other values, we can see that there's nothing else that's shared between all of the values. Okay, so if I take out these common factors, all the common factors will leave me the greatest common factor. Taking out 4x. So I found my greatest common factor, it's 4x. That's my first step to factoring. Then I will factor it out. Okay, basically what that means is I'm going to divide each of these terms by 4x. Okay. Now, when I factor it out, what's left will be 4 divided by 4 is 1. X cubed divided by x is x squared. 12 divided by 4 is 3. X squared divided by x is just x. 8 divided by 4 is 2. X divided by x cancels each other out. Okay? So my GCF is 4x. My factor after I take out the GCF is x squared plus 3x minus 12. So my final answer will look like this. GCF on the outside, remaining factors on the inside. This is 4x cubed plus 12x squared minus 8x factored out. Okay, so notice that when we're done, our problem looks like the beginning of a multiplication problem. Okay. A good check is if we multiplied it out, we should end up with the same terms that we started with. And that's how we can tell that we did it all the way correctly. Okay. So we've got some more examples here that I'll go through. These first two, and then a little less time, but go through some more. Alright, so with this first example, notice how long we took. We took all the factors, we listed them all out. Now I don't expect you, won't expect you guys to do that each time, but you should look, and if you can recognize, the better that you are at recognizing the factors that these two numbers share, two terms share, the faster it will be for you. So I look at these numbers and I see that 5 and 10. I know that 5 goes into 10 evenly, okay? And that's the biggest number that it can be because that's the biggest number here. So I know that 5 is going to be part of my greatest common factor, okay? Looking at the V's, there are 3 V's in this one and 5 V's in this one. So there's 3 V's common between these two. So 5V cubed and so when I factor this out then, 5 divided by 5 is 1. I can basically do it like this. V to the 5th divided by V cubed gives me V squared. 10 divided by 5 is 2. V cubed divided by V cubed is just, well, it's 1, so I don't need to write there. 2 times 1. Okay? And so now, my answer, just like here, it's the beginning of a multiplication problem. Okay? I can do the same thing here. If I'm looking through my numbers, I have 4, 2, 6. What goes into all of those numbers? 2. I have b cubed, b squared, b. Okay, so I have a b that is common in all those values. So now I'm basically just dividing each of these by 2b. Dividing this by 2b. Dividing this by 2b. Okay, and so I'm left with 2b squared from the first term minus, keep that sign the same, b minus 3. Okay. A few more examples. Okay. If you got it, you can just go through on your own. If not, then you can follow me. Alright, 3, 12, 15. I recognize that 3 is going to be my common factor between those values. There's at least one x in all of these. So I have x squared left after I divide by 3x. 12 divided by 3, that'll be 4. X squared divided by x leaves me with x plus 15 divided by 3 is 5. X divided by x, just 1, doesn't need to write it. Okay, looking at these values, 4 goes into each of them. Okay, so 4. X goes into each of them. Now I have 2x, okay, minus 3. Okay, and each time I should make sure as I finish that there aren't common terms left inside here. Okay, and I'll show you that what can happen if you take out a number that's not the greatest common factor with f. So final example here, our final two examples, kind of similar to A, but I see 5 and 10, so I want to take out 5 out of here. There's a d in each, so I want to take out d. Okay, 5d gives us d squared. 10 divided by 5 is 2. D divided by d is 1, so it doesn't need to do that. Alright. Is that the same problem? Oh no, I guess there's a different, okay. And then here, just so we can see what happens, I'm going to take out something that's not the greatest common factor. So if I'm looking at these problems and I say, oh, these are all even, I can take out 2 and m. So let's say I factor out 2m. I'd be left with 3m squared minus 6m minus 12. Okay, so looking at the factors left inside here, or the terms left inside here, you should recognize that they're all divisible by 3. I could take out another 3. So I'm going to do that. I'm going to take out 3. Okay, I already have 2 of them out here, but I'm going to take out that 3. Well, that means I'm dividing everything here by 3. I'd have m squared minus 2m minus 4. Okay? And so, now inside here I don't recognize anything that's shared between all these. I have 2 and a 4, but a 1 here. Basically a 1 here means I don't have anything else that I can take out of everything. I don't have a variable here, so I'm done. I've done everything I can. Okay, but I've taken out another factor, so on the outside I will multiply these together just to get all the way simplified. And here it is factored. Okay, so what we did here, we basically took multiplication backwards. We factored the problem using the GCF, the greatest common factor. Okay, and the greatest common factor you can find it a couple different ways. You can factor it out like list by list like I did here. I know that'll become tedious after a while, but recognizing the values just by looking at the numbers is a little bit easier. And even if you get to the point where you take something out that's not the biggest number and you recognize it later that you have 3 or something else in there, you can take it out here and kind of reconcile that problem pretty quick. Okay, so hopefully you know how to factor out the GCF. We will look at some more practice, and we'll get into factoring trinomials and all the good other polynomials later. Alright, have a good one. See you tomorrow.